Hello everyone and welcome to my session about the Reality Toolkit interaction framework at this year's Global XR conference. My name is Dino Fezic, I will be your speaker today and I will walk you through this exciting new feature that is currently available in the preview release of the toolkit. The interaction framework is a pretty exciting addition to the toolkit because so far the toolkit was a great framework. I'm using it on a daily basis in production apps and games, but there was always this big gotcha where you had to reinvent the wheel, write your custom interactions with a lot of code, and there was no out-of-the-box solution for this. Now we have an out-of-the-box interaction solution that works cross-platform and that you can use to create amazing games and apps for business, for entertainment, and so on and so forth. So since this is a pre-recorded session, you cannot ask any questions on the go, right? But feel free to reach out in the Discord of Global XR. I'm available there. Also on these slides, you will find my contact details. So never hesitate to ask any questions you might have. I'm one of the contributors to the Reality Toolkit. As I already mentioned, I use it on a daily basis in apps and games for development, and I'm pretty sure I will be able to help out with any questions or issues you might have. So yeah, let's get started. All right, everyone, here we are. Let's get started. What are we going to talk about today? So today we will take a brief look about the Reality Toolkit and then how to set up the project. And then our main guest of the evening is the interaction framework and the sample scenes and interaction development, just to show you how you can set up things and also how to navigate through our samples and understand things. Then we will already wrap up. So it's a pretty short session that is supposed to give you some of the details and introductions to the features, but we won't go into too much depth, with specific things. So as I already mentioned, if you have any specific interactions that you need to set up, do let me know, because we are always looking for very specific solutions that people need to develop so we can make sure that they are easy to create with the interaction framework out of the box. Yeah, so this session is not generally about the Reality Toolkit, so we won't spend too much time there, but I will show you briefly how to set up the project and what it is. But if you want to learn more about the Reality Toolkit itself, then please feel free to check out the documentation and the website, and just get started using it, and I think that's the best way to learn. So what is the Reality Toolkit? The Reality Toolkit is an open source, free development framework for Unity, for XR apps and games. So it's only available for Unity, and it will always be available for Unity only. It's a Unity framework. It's cross-platform by design and heart. That means whatever we create for the Reality Toolkit, we make sure it runs on all major platforms. And yeah, you can build with one click to all of those platforms. So compared to the Meta Presence platform, we might not have all of those features available as of now, but whenever we add a new feature, just as the interaction framework, we make sure that it runs on Pico, on Meta, on I don't know, Steam, on OpenXR. We make sure that it runs on everywhere where you can deploy a mixed reality application, XR application. It's not maintained by any corporation, it's just maintained by a couple of people, community maintained. Everyone can join, make PRs, and add features. Of course, we don't add anything. Don't let anyone add anything to the official repository, but it's very easy and friendly to get started. Just create your first PR, and we will make sure it fits into the system architecture and discuss with you how to add it, and then we'll be adding it. So what never happens is that we will deny any features or code added only because it's not ours or something. So make sure to check it out, create your fork, and let's get started making it even greater than it is. Yeah, as I mentioned, it's only for Unity engine and editor use, and we have no plans as of now because of capacities to make it work in any other engine. So the history of the Reality Toolkit is simple. Some time ago, it was around 2016 or maybe end of 2015, there was the Holo Toolkit. You might have used it or not. It was a great toolkit for Unity as well. That was basically for HoloLens development. It was back then when the first HoloLens device launched. And it was pretty cool. Then at some point, the Holo Toolkit became MRTK, the Mixed Reality Toolkit. We all know and love it. And then at some point, also Unity came up with their own solution, which is the XR Interaction Toolkit, is XRE, which is also a cross-platform toolkit for XR development in Unity. And yeah, the Reality Toolkit is just another approach. It makes some things differently. It uses some same things as the others. So it's really like a love child of MRTK and XRE and the Holo Toolkit. Once you started using it, you will notice there's some very familiar things to it and some new things to it. So it's really user-friendly and easy to get started. The Reality Toolkit is maintained on GitHub. There is an official Discord where you can join and ask questions and showcase your stuff. It's pretty, we are just getting started setting it up, so feel free to join and help us spread the word. Other than that, you can check out Reality Toolkit at realitytoolkit.io. You can also visit realitycollective.io. That's what the Reality Collective is, like the collective maintaining the toolkit. We also have a service framework, which is another package that you can use. The Reality Toolkit actually builds on top of the service framework. It's a service locator system for Unity. You are using it in MRTK, for example, on a daily basis, and it's also being used by the Reality Toolkit. You can also use it standalone, and I really recommend taking a look at it because you can use it to implement your own business logic, your applications, and make sure you have a solid, bulletproof and enterprise level, maybe software architecture in your Unity projects. Yeah. And as I mentioned, there is the Reality Toolkit documentation. It looks pretty similar, and that is where we can get started using it. So let's return to my beautiful slides. So just real quick, how do we get started setting up a toolkit project? Pretty simple. Open your project, create a project, add the OpenUPM scoped registry to your package manager by adding, the URL and the two scopes, com.realitytoolkit and com.realitycollective, because the toolkit has some dependencies on the, packages published by the Reality Collective. Once you have done that, in your package manager, you will see that there is a bunch of packages by the Reality Collective available for you to install. And yeah, once you have that ready, you just install core and camera. That's the least you should do. The core is where the interaction framework lives and all the foundational stuff is. And camera is an XR player controller, basically. It comes with 3 different prefabs for different scenarios of XR applications, depending on what kind of player controller you need. And I really recommend getting started with core and camera. If you like, of course, there is more packages. There is the device simulation, which is for simulating input devices and hand tracked hands, for example. There is DevTools, which gives you for example, an in application console that you can use. You can monitor some system resources like memory and frame count and stuff. There is Locomotion, also a really great package, that has smooth locomotion, teleporting, all different kinds of teleportation, with a instant teleportation, smooth teleportation, and so on and so forth. So you should definitely check that one out as well. Once you have core and camera and locomotion, in my opinion, you already have like a lot of systems in place out of the box that are pretty common for modern day XR applications and VR applications. Then we have the Meta Platform package, which you should install if you plan on deploying to the Quest, for example. And you have the Pico package, for example, if you want to deploy to Pico, of course. So once you have that, just wait for it to complete. You can actually, by now in Unity, you can install multiple packages. Just a hint, you can select multiple packages in the package manager and then it will install all of them. You don't have to install one and then wait for it to complete, then install the other one. It's a pretty cool addition in my opinion. So once you have done that and you are in your scene, in this case it's just a Unity sample scene in the screenshot on MT1, go to Reality Collective, Reality Toolkit Configure in the menu toolbar at the top of the Unity editor, and it will automatically set up and configure your scene to make use of the Reality Toolkit. Yeah, so that's what this looks like. You will notice your camera was removed. You have an XR player controller in place instead that has everything you need to make your player move around and collide with stuff and climb stairs and everything if you like. Then we have the Service Manager instance, which you might be familiar with if you are already using the service framework. That's where all the services live that the toolkit is made up of. Yeah, here we are, guys. So that was everything about the Reality Toolkit. As I said, if you have any questions about setting up the toolkit and the toolkit in general, make sure to ask them in the Discord or wherever you like. Really reach out to me and I will be happy to help. So I know this was pretty fast and very basic introduction to the toolkit. So what we are looking at right now is a screenshot from the interactions framework sample scene that we have set up. So in this scene, and we will be walking through it in a minute, in this scene we have set up a couple of samples for common interactions like grabbing stuff, pushing buttons and toggles, from far or from close up, poking things and interacting with Unity UI. So that's where you will find all of that, and you can basically just use it as a blueprint for setting up your own interactions. Okay, so we are now in the Unity editor in the sample scene that I just introduced. So let's take a look at how this thing is set up. A word of notice, at the time of recording this, we actually did not finish the sample scenes completely yet, so you will notice in this recording that I'm basically using a simple grenade mesh for everything. Of course, it's just, imagine it's a placeholder. We will be adding different items, different meshes to simulate different stuff. But for now, this grenade was just our first, prop that we used for implementing these interactions and showcasing them. Okay, so as you can see, I'm here at the direct interaction only station. And there's a bunch of grenades here that you can interact with only directly. That means you cannot interact from afar. You have to get close and grab them and throw them and whatever. So I will select one of those, and then we can take a look at how it's actually set up. So with the interaction toolkit, you will need not a capsule collider, any kind of collider on the object and a rigid body. So that's a prerequisite. And if you add those two, so a collider and a rigid body, you will be able to add the interactable component. If your game object does not have any of those, you will get a warning by Unity that it's the interactable component requires a rigid body and requires a capsule collider. So yeah, and once you do that, once you have that in place, like in this case, you can add the interactable component to your game object that you want to interact with. This signals to the system that this is an object in your world, in your game world, application world, that we can interact with. And it has a bunch of properties like a label. This is an optional label, so you can use labels to group and categorize interactables. It's pretty similar to the Unity tag that you can put on a game object. So it's like an additional tag that you can use. This is useful when you want to find all grenades, for example, or find, if your label is unique, you can use it like a sort of ID to find one specific interactable. Imagine your user interacts with stuff and they pick it up and they drop it somewhere and it gets lost, for example, and you want to make sure, this is one scenario how you can use it. You want to make sure that it resets to its original position, and you can use the label to find it, for example, and then make sure to reset it to where it belongs to. These two checkboxes we have, direct interaction and far interaction, are available to define how we want the player to interact with this object. Since this is the direct interaction only station, the far interaction is unchecked. That means the player won't be able to use far interactions like a raycast to grab the grenade from afar. We have a select action always and a grab action. A select action is the input action that you perform, that you want the player to perform on their controller, for example, a specific button or something that should trigger selection on this interactable. And the grab action is the same thing. It's just what defines what has the player to do, which input action am I listening for to trigger grab and make the interactable attached to the player, for example, or the player's hand. Yeah, and then we have focus mode, single and multiple. So this means single means this interactable can only be interacted with by a single interactor, user's hand, for example. And multiple means it can be focused and interacted with by multiple interactors. So what are interactors? If you know the Unity XR interaction toolkit, it's a pretty familiar term for you. Essentially, when it comes to the interactions, there is two players. There is the interactable and there is the interactor. So the interactor is always interacting with the interactable. We have in the toolkit a bunch of available interactors like the direct interactor, poke interactor, locomotion interactor. Teleport interactor, and did I forget one? There was another one. I think did I mention it? Direct interactor. Doesn't matter. We have a couple of them already in place that you can use out of the box, and you can also write your own interactors, but that's sorts of advanced usage, and I don't think you will ever have to actually. Yeah. So, and activation mode is, you can define here how this interactable is activated. So if you set this to button, then basically you can use activation events on this interactable that will just fire like a regular click event. If the user selects it, then it will fire a click event essentially. If you set this to toggle, that means that it behaves like a toggle. If the user selects it, it becomes activated and stays activated until the player selects it again, which makes it deactivate. Yeah, but we will see usage of that in a minute. And that's the interactable for you. It's the foundational component that is necessary on any object that you want to interact with. And once you have that, then interaction behaviors come into play. And this is where the Reality Toolkit interaction framework really differs from Unity's XR interaction framework toolkit or the MRTK. So it's not all in the interactable. We wanted to create a system that is, dynamic, adjustable, where we can stack different things together, combine different behaviors to create new behaviors, and so on and so forth. So essentially, just as Unity has game objects that you attach multiple mono behaviors to, we have an interactable that you can now attach, as many as you like interaction behaviors to. So the toolkit comes with a bunch of predefined interaction behaviors that you can use to achieve all kinds of interaction effects. There is for example, in this scenario, change material behavior. So this is an interaction behavior that will change a renderer's active material depending on how it's being interacted with. And you will notice all of these interaction behaviors that we are seeing right now, they have two properties in common, which is the sorting order and target-handedness. So the sorting order defines in what order should interaction behaviors be triggered and updated when I'm interacting with this object. By default, they will be all in 0, and that means the order is exactly the same order that you can see these components being attached to this game object. So if I drag this one up one level, then it will be updated, before this at the top. And if you have some custom sorting that you need, then you can use this property. Essentially, I don't think in most cases you will need to update this order manually. The target-handedness is also very useful if you want a specific behavior to only trigger or be active when a specific handedness is in place. So if I'm grabbing something with my left hand, I might want different things to happen that when I do it with my right hand, and we will actually see a usage of that in a minute. So let's keep going. So we saw the change material behavior. It doesn't have a lot, it's very simple, just a bunch of properties. Materials you can assign that should be applied to a mesh renderer when interacted with. So the next one we want to take a look at is the object update rigid body behavior. It's pretty simple. So this one is useful, and you most likely want to use it if you have physics enabled. So for example, when the player grabs something like a grenade, we want to disable gravity, for example, and make sure that the object doesn't fall to the ground and so on. So the update rigid body behavior will make sure that your rigid body is always updated to fit the current interaction and usage. And then there is the grab behavior, which is, the actual grabbing. So this one will make sure that the object, the interactable being interacted with, is actually attached to the player's hand, for example, when interacting. And there is a few properties you can use, like local offset and local rotation offset, that you can use to make sure when this object is being grabbed, it should be positioned in a specific offset relative to the hand's position. So that was that. So let's move on and do a quick look at the far interaction only samples. So essentially this is all almost the same, except that we only allow far interaction instead of direct interaction. Let's take a look at the interaction behaviors here. So we have a translate behavior here. Actually, we are still looking for a better name for this one. But translate doesn't have to do anything with, translating text. It just means that this object can be moved around. As I grab it and I move my hand, it's like it's wired to my hand, and it will move along and translate in space to where I point at, essentially. So that's that. And so let's keep going and see this one. So these two, this allows far and direct interaction. And then we have UI elements. This is where things get like interesting again. So we have two different kinds of buttons essentially here. So we have a button and we have a toggle. Let's take a look at the button first. So as I said, we use this activation mode to define how this interactable should be activated. And it should be activated like a button because we are building a button. So in this case, we also have a pretty interesting behavior in place, which is the focus hand pose behavior for the left and right hand. So as you can see here, we have defined different behaviors depending on whether it's the left or the right hand. When I'm using my left hand to focus this button, then I use a different pose than with my right hand. Poses are pre-recorded hand poses. So if you are using a rigged hand mesh or if you are using hand tracking, it doesn't matter, then we will actually use this pre-recorded hand pose to, make the hand fit the shape of the interactable, for example. And if you're holding an apple, you will have maybe like your hands like this. If you're having holding a gun, then you will have your hand like this. So those are hand poses that we can pre-record. The toolkit comes with a hand pose recorder that we can use to record all kinds of hand poses and then use those recorded hand poses when interacting with stuff. So that's what the focus hand pose does. Then we have the focus lock behavior, which will make sure that we are locking focus on this interactable while the select action is pressed. So it just makes sure that as the user moves the hand around, we don't drift off the interactable and lose focus. We have poke response behavior, which is a behavior that makes we use it to make the lever on the button, the actual button mesh, follow the hands, my fingers position in space, and it will visually appear as if I'm pressing the button. We will see it in a demo in a couple of minutes. And then we have the button behavior, which is essentially just similar to the UI button. You can just register a bunch of click handlers here that will be notified whenever this button interactable is pressed. Toggle should look fairly similar. Also, similar to the Unity UI toggle, we have a value changed with a boolean, so this event will erase whenever the activation has changed on this toggle. And that's it. That's already all there is to say about the UI elements here. So for Unity UI, it's actually pretty simple. All you have to do to make this work is, add the interactable canvas component to your Unity canvas. So you just use your world space canvas and then you add the interactable canvas component to it, and this will make sure that interactions work on it. Alright, so this is me at the far interaction only station in this demo scene that we just talked about. So with these, you can see I have my far interactor, and I can highlight these interactables. We can they receive interaction events, and I can actually grab them, and move them around. So this is far interaction for you. That you can, those are limited to far interaction actually, as I said. So I can actually only interact with these from afar, and we will look at the others as well. Okay, so now I'm at the UI elements station, and as you can see, when I get closer to this button here, this is where the focus hand pose behavior comes into play. So once we start focusing this, you can see my rigged hand mesh changing poses into a sort of poke pose that I can use to press this button. So as you can see, this is just a combination of different interaction behaviors working to accomplish this effect. And all of this is available out of the box. So this one is a toggle, so we can move this little thing around, and that's just two very simple examples of how you could create custom UI elements for your application using the interaction framework. So, for direct interactions, I actually made a spontaneous quick change of plans, which is something you should never do. And I figured, why show the sample scenes we have when I can actually show something from one of my own projects as well. So what we are seeing here right now is one of my MVP projects that I'm currently working on, which is a game where race with your boat. And so I have a couple of interactions here that we will look into, and actually these are direct interactions, the one that we're still missing to look into. And as you can see here, I can use my hand to grab this sorts of steering wheel. I can use my other hand to grab it, and I can also grab with both hands. And there's multiple out of the box interaction behaviors in play here. So by grabbing this, my hand changes its pose slightly. It also the controller visualizer, which is a rigged hand mesh in this case, is basically now attached to the steering wheel, and it stays where it is, even though if my controller is basically not in line with it. So that's just useful to keep immersion going, because if my hand is always where my controller actually is while grabbing the steering wheel, then it might drift off, and it just looks weird if the steering wheel is moving, even though my hand is sorts of drifting away from it and not actually grabbing it. By making the visualizer, the controller, stick to the actual interactable, it increases immersion a lot in VR. So that's one interaction we have here. We also have this lever that is also, same thing. I can, this is where I increase the throttle, and I can grab it and move it up and down. And this is actually also mostly out of the box behavior that we have here for interacting with this lever. We have another custom hand pose. When grabbing it, it's also stuck to the handle, to the lever. It moves with the lever but does not move to precisely where my controller is, for the same reason as the steering wheel. So for this, we will now look at the code next to see how it's made, how I implemented these custom interactions, and how you can do the same thing for your own interactions. All right, let's look at some code real quick. How did I set up the steering wheel? So the steering wheel only has one custom interaction behavior. Everything else is out of the box with the toolkit. For the steering wheel, I implemented this C# script called steering wheel. It's it inherits base interaction behavior, which is a toolkit base component that you can use. So whenever you implement your own interaction behavior, you want to make sure that it inherits base interaction behavior. And then I define this is all custom. I'm setting some limits to how much the steering wheel can rotate, and then I'm setting a reset time that when I drop it, when I'm not holding it anymore, it should reset itself to neutral automatically. And I need to know what the up transform is to do some maths, calculating angles, and everything else is not really important for the interaction behavior itself. So we have a current steering angle, and we have a current steering normalized, where -1 indicates it's full left steering and 1 indicates it's full right steering, and just an event to receive this updated normalized value. But what we really want to look at is actually pretty simple. So once you have your component inherit base interaction behavior, you can do, for example, public protected override on first grab entered. So this is raised on your interaction behavior whenever the first interactor starts grabbing the interactable. And then we have on the other side, on last grab exited, is when the last interactor has stopped grabbing your interactable. So in case of the steering wheel, I grab with one hand, that's the first grab entered. And if I grab with another one, it will still fire all the events and attach the visualizer and stuff. But really, the steering wheel behavior will actually ignore that second interactor. It will just be there and it will be stuck to the steering wheel, but it's not influencing the steering itself. That is, as of now, only happening using the first interactor to grab it. And then other way around, when I drop my first hand, then the that what used to be the second interactor now becomes the first one, and I can use that to do the steering. And let's take a quick look just into the base interaction behavior that you can use to implement your own. You will notice there is a couple of events you can use. Event um, on first focus entered, on first grab entered, on first select entered, and stuff. So there's always enter and exit. So for every kind of event, there is a pair of enter and exit handlers that you can use, overrides. And yeah, and you just it depends on your behavior. You just gotta think, okay, do I care about selecting or grabbing? Do I care about the first one to do it, or the any? You can actually use on first grab entered or on grab entered. On grab entered will execute for any grab that happens. It doesn't matter whether it's the first one or the second one or whatever. So it just keeps going. Yeah. So once the first grab entered, we look at the interactor, and in this case, we only care about controller interactors. So we check if the interactor is not a controller interactor, then we just return and exit early. So because we don't care about that kind of interactor for this behavior. And if it is, we save a reference and then we calculate the steering angle, which is just a bunch of math to, calculate the, what is it, the y plane, and then compare the position of the controller, the interactor as I move around. I calculate the delta on the XY plane, and that gives me an angle that I use to rotate the steering wheel back and forth. That happens in the update. So every frame I do this kind of math, and then I rotate the steering wheel transform to fit that angle delta. And that's basically all there is to it. So let's take a quick look at that throttle lever as well that I showed briefly, which was, it's pretty much, you already guessed it probably, it's pretty much the same logic. So again, we have a current throttle normalized, which is just for knowing how much throttle we are giving to the boat, to the engine, whatever. And then again, in the update, I do some maths here, and that's basically it. I just calculate, in this case, it's the XZ plane that we use to, calculate the movement of the controller every frame, and then we can use that to, rotate that lever so it visually appears as if I'm holding onto it and rotating it. But again, so this behavior again inherits base interaction behavior and then uses, yeah, it actually uses the same pair of overrides here on first grab entered and on last grab exited to, handle interactors moving around and interacting with this thing. And that's two examples of how you can implement your own behaviors. It all starts with just creating a script and making it inherit base interaction behavior, and from there everything's there for you to use. You just have to think about what does your behavior look like, what do you want to happen when the interactor starts interacting with this target, and then you just implement your custom logic, which I don't know what you need, but let me know, and if you get stuck implementing, I'm happy to help. And that's it, folks. We have completed our tour through the some samples of the interactions available that come by default from a toolkit. So to summarize, the interaction framework is a cross-platform interaction framework. That means as even though I was using Meta Quest devices, these interactions work the same way on Pico as well, Pico 3, Pico 4, on any OpenXR supported device. Basically, it's powered by the Reality Toolkit and its services that it brings. It has many out of the box interaction behaviors that you can combine, stack, and just create amazing interactions using those out of the box behaviors. If that doesn't suffice, then it's very easy to create your custom behaviors and extend the existing functionality with some of the stuff that you need. And actually, if you implement something that is that you think is pretty great and it doesn't come with the out of the box behaviors, then please consider making a PR and just adding your custom interaction behavior to the toolkit so others can use it as well. Thank you for watching in this case and listening, of course. And yeah, let's connect in code. Feel free to reach out and ask any questions. I said it a couple of times. I say it again. Find me and ask questions you have, and I'm looking forward to talking to you.